That's a very little one. That's going to complain to management. It'll be all right. My guess for the average would be, what would your guess for the average be? What is there the most of? The average should be close to what? It should be close to 0 because 60% of the data are zeros, right? So the average of these numbers by themselves would be 1.5. But there aren't equal amounts of each number. So what's the heaviest weighted number? 0. So the average is going to be closer to 0. Let's see real quick. It's xp of x, 0, 0.2, 0.2, 0.3. I get 0.7. So way below the 1.5 it would have been if those were just 4 numbers, right? So that's what I mean by the heaviest weighted thing kind of like tries to pull the average towards it. That's what happens. Maybe. Okay. All right, now we need to discuss how am I going to do standard deviation in this format. So the reason I want to take a minute and make sure you understood that I take the weight times the value. And what's the difference between, what was the old formula for mean? What was the old formula for mean? Tell me in English, and then we'll try to remember the symbols. Sum of x, right? Add them up, divided by how many there are, right? N always represents the number of things you're looking at. Really good choice. Number starts with N. It's crazy how creative we are. So what's the difference between, what in symbols, what is this? What did we do to get this? We could do this. What did we do to get this? We added up, so of course that's going to be this. Now, these look very different. But I want to remind you, what is on the bottom of any probability? The total number. Oh shit, it's the same stupid formula. Do you guys see that? Right? Yeah, bam is right. So it's like that old ragu thing. It's probably too old for most of you. It's in there, right? So inside the probability is the over n. So these are the same stupid formula. They are. I suck the over n into each probability. So what does that have to do with standard deviation? I don't know. I forgot. Let's see. All right. So this is not going to be what we're going to do, but I got to get there, okay? So I don't know how you want to do your notes, but if I were you, I would do this. This is the idea behind this. So what I would probably do, what's the standard deviation formula from before? X minus, and let's do mu right now. And why? The only reason I have to use population symbols is because what's on the bottom of P of probability? N. And if it was supposed to be sampled, it would have to be N minus 1. Right? So since that's an N, let's use population symbols. Let me stop right there. That's just a little walk down memory lane. That's the formula for standard deviation. Right? So do you see here's the formula for mean, and instead of dividing by n, we multiply by the probability. Why? Because probability has n underneath it already. So here, what am I going to do? Instead of dividing by n, I'm going to multiply. Oh shoot, I was supposed to move it away. Put the real thing here. Each deviation by its probability. So, for example, this data value has a deviation, right? But how many times does it happen depends on the probability of that thing. If it was 60% chance, it's going to happen 60 times out of 100. I want to multiply it by 60 out of 100. I want to multiply it by its weight. The same way I multiply the values by their weights. Now, this sucks. This is the conceptual equation. So this is the equation for standard deviation. I'm just going to play with it a little bit. That's the formula. Let me make it a little more clear what's happening. So you take x minus the mean squared times p of x, and then you add them up. But there's a lot of freaking work involved in that stupid little thing. I want to make it so I only have to do one more column, and I'm done. That's what I want to do. That's crazy. That's just the way I am. So this is what I call a conceptual equation. And I want to create what I call a computational equation, the one I'm actually going to use. It's the same equation as this. I'm just going to work it out a little bit. I'm going to put it in a different format. So why is this a conceptual equation? Because what's the idea of standard deviation? It is the average distance from the mean to the data point. So can you see that? You can see that. The distance from the mean to the data point. You can see it in there. So the concept is in the equation. Now I'm going to go and screw with this. I'm going to start multiplying shit out and working with it a little bit. So I'm going to lose the concept, but make a better computational equation. Does that make a little bit of sense? Okay, so here's the most pure, straight-up algebra you'll see in this class. I'm going to work with this stuff. Okay, let me make some room. Oh, this is exciting. Somebody help me out. If you were in algebra class, you wouldn't know what the hell that was, but you know what to do with this crazy thing, right? Turn on your algebra brain. Is the right answer x squared plus mu squared or something? And hell no. How do you do this correctly?
Multiply by itself.
Multiply it by itself. I love it, because that's what square means. Now, please don't freak out too much. We're not going to do this too far. I just want to do the first few steps and then show you what it looks like at the very end. You could have an entire semester class dealing just with the algebra of summation symbols. I'm not going to do that to you. But I do want to be able to at least show you the final form, and you can see where it would come from a little bit. Okay. So this is not my final form yet. Go freeze it. So what do you get when you start to multiply this up? X squared. Yeah, you get 2 x's, right? 2 mu x.
Plus mu squared.
I'm just going to do one more step. There's like 7 more steps here. I'm just going to do one more step so we can at least see the first part of what it's going to look like. I would then do what with this? Distribute it. So I get x squared times p of x minus other shit. All right. Trust me, the other shit, we keep going, do some weird stuff. Mu is the sum of x over n. We could use that shit, and oh my god. Or backwards even, we could do so. It's crazy. There's a lot of simplification to do that I'm not going to get into. And what you end up with is this. You end up with that formula is the same as this. Believe it or not. I really want you to see why that's really cool. I just need one more column to get what I need for that formula. I already have x p of x. What does the formula need? It needs to be able to add up x squared p of x. So there's kind of 2 ways to look at this. The way I look at this is, I already have x p of x. I can't just square it though. Is that cool? If I square x p of x, I get x squared p squared. Shit, is that what that needs? No. So what am I missing that I need? I got 1x, I need x squared. So I can just multiply by 1 more x. If I just multiply, I'll call these L1 and L3. We'll start to see we're going to do some of this in our calculator, very likely. If I multiply this times this, what's x times x p of x? X squared p of x, which is exactly what the formula needs me to be able to add up. This is L1 times L3. So I get 0 times 0 is 0. 1 times 0.4 is 0.4. 2 times 0.6 is 1.2. 3 times 0.6 is 1.8. Yeah, 3.4. So you get sum of x squared p of x is 3.4. Now, is that the variance yet? No. So just like before, I've got to take the number and put it into the formula, right? So if I put that into the formula, let me put it up here. Those are in the background, like screen. So here's the formula. What do I replace this with? 3.4 minus 1.6 squared. And that's going to be the variance, right? 2.56, 0.84, maybe? I don't know why I'm even, oh yeah? And then take a square root, it's like 0.9 something. 0.92. Standard deviation goes at least, you guys should know this by now, especially if you lost points. At least 3 places. So 0.9 who? 0.916? 0.917? Okay. Crowdsourcing the work. So, when you look at this, you kind of lose a little bit of the idea. Like I try to tell you, this is a conceptual one. You can see the part of the standard deviation here. And you remind yourself that P has an N on the bottom. So this really is the exact same formula that we used before, but it just so desperately sucks you. I need a few more columns to get that sucker built. I just want one more freaking column, please. Thank you very much. So we work with this a little bit. That is equivalent to this, which is very quick and easy to get. So let me give you, yes?
So the 3.4 represents what?
The 3.4 is just a part of the standard of the variance equation, right? Just like it was before, when you added the column up, you had to put it over n or n minus 1. It wasn't the variance yet. Same way that it happened before. So let me give you this handout. You know, I was going to have a handout about this. One side is worked out examples, and the other side is what I want you to do right now. So if you want to borrow a calculator, I've got some up here. One more. So again, you can work together if you want to. It's obviously not a quiz.